The practice of using oversized conduit for lighting home runs without upsizing the conductors constitutes a clear violation of the National Electrical Code, commonly referred to as the NEC. The NEC meticulously outlines specific requirements concerning the appropriate sizing of conduit, which is directly predicated upon the quantity and dimensions of the conductors housed within it. Deviating from these prescribed guidelines by employing oversized conduit introduces a tangible risk of conductor overheating, thereby elevating the potential for electrical fires. The role of electrical inspectors within a given jurisdiction is paramount in upholding safety standards and ensuring strict adherence to the NEC regulations. When inspectors knowingly permit the utilization of oversized conduit without requisite conductor adjustments, they are effectively neglecting their mandated responsibilities and compromising public safety. The core issue surrounding oversized conduit stems from its impact on heat dissipation. Conductors generate heat as electricity flows through them. The NEC specifies conduit fill requirements to ensure adequate airflow and heat dissipation. When a conduit is significantly larger than necessary, it might seem like there's more space, but this can actually reduce the efficiency of heat transfer. The conductors can overheat because the air inside the conduit becomes stagnant and acts as an insulator. Overheating can degrade the insulation of the wires, leading to short circuits, ground faults, and potentially fires. NEC Section 310.15 addresses ampacity, the current carrying capacity of conductors. This section provides tables and guidelines for determining the appropriate conductor size based on factors like ambient temperature, the number of conductors in a raceway, and the type of insulation. When the number of current carrying conductors in a conduit exceeds 3, NEC Section 310.15 cone requires ampacity adjustment factors to be applied. These factors reduce the allowable ampacity of the conductors to prevent overheating. Using oversized conduit does not negate the need for these ampacity adjustment factors. Ignoring these factors can lead to conductors operating above their rated temperature, which degrades the insulation and increases the risk of failure. NEC Chapter 9 provides detailed tables for conduit fill. These tables specify the maximum percentage of the cross-sectional area of a conduit that can be occupied by conductors. The fill limits are designed to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation. Even if the conductors fit within the oversized conduit, exceeding the fill limits can still lead to overheating. The NEC also addresses the proper support and securing of conduits. Oversized conduits can be more difficult to support properly, which can lead to sagging or damage. This can put stress on the conductors and increase the risk of insulation damage. Furthermore, the use of improper fittings and connectors with oversized conduit can create points of weakness in the electrical system. These weak points can be susceptible to moisture ingress, corrosion, and mechanical damage, all of which can compromise the safety and reliability of the installation. The NEC requires all electrical work to be performed in a neat and workmanlike manner. The use of oversized conduit without a valid engineering reason can be considered a violation of this requirement. It can create a cluttered and unprofessional appearance, and it can make it more difficult to troubleshoot and maintain the electrical system. Proper documentation is crucial for electrical installations. When oversized conduit is used, it should be clearly documented in the electrical drawings and in the project specifications. The documentation should explain the reason for using oversized conduit and should include calculations to demonstrate that the conductors are adequately sized and protected. Without proper documentation, it can be difficult to determine whether the installation complies with the NEC. The potential consequences of using oversized conduit without proper conductor sizing are significant, ranging from equipment malfunction to electrical fires. Electrical fires can cause property damage, injuries, and even fatalities. In addition to the immediate safety risks, non-compliant electrical installations can also lead to legal and financial liabilities. Building owners and contractors can be held liable for damages caused by electrical fires that result from code violations. Moreover, insurance companies may refuse to cover losses resulting from non-compliant installations. To mitigate these risks, it is essential to adhere to the NEC guidelines for conduit sizing and conductor ampacity. Electrical engineers and contractors should carefully review the electrical drawings and specifications to ensure that the conduit and conductors are properly sized. Electrical inspectors should thoroughly inspect electrical installations to verify compliance with the NEC. When violations are identified, they should be promptly corrected. Continuing education is also crucial for electrical professionals. The NEC is updated every 3 years, and it is important for electricians, engineers, and inspectors to stay up to date on the latest requirements. Training programs and seminars can provide valuable information on code changes and best practices. Public awareness campaigns can also help to educate homeowners and business owners about the importance of electrical safety. These campaigns can provide information on common electrical hazards and how to prevent them. Reporting electrical code violations is an important responsibility. If you observe oversized conduit being used without proper conductor sizing, report it to the local building inspector or electrical authority. Your report can help to prevent a potentially dangerous situation. In summary, the use of oversized conduit for lighting home runs without upsizing the conductors is a violation of the NEC. This practice can lead to overheating, fire hazards, and other safety risks. It is essential for electrical professionals and inspectors to understand and enforce the NEC requirements for conduit sizing and conductor ampacity. By working together, we can ensure the safety and reliability of electrical installations. The NEC is not merely a set of arbitrary rules, it is a comprehensive framework designed to safeguard lives and property by mitigating electrical hazards. Strict adherence to its provisions is paramount in ensuring the safety and functionality of electrical systems. When deviations from the NEC occur, the potential for catastrophic consequences escalates significantly. Furthermore, the consistent enforcement of the NEC is crucial in maintaining a level playing field for all electrical contractors and ensuring that all electrical work is performed to the highest standards of safety and quality. Neglecting to address these violations undermines the integrity of the electrical system and places inspecting individuals at undue risk. Therefore, it is imperative that any observed instances of oversized conduit usage without corresponding conductor adjustments be promptly reported to the appropriate authorities. Firstly, the physical principles governing heat dissipation dictate that conductors operating within confined spaces generate heat due to electrical resistance. The NEC mandates specific conduit fill requirements to facilitate adequate airflow and heat transfer, thereby preventing the accumulation of excessive heat. When oversized conduit is employed, the seemingly ample space within can paradoxically impede heat dissipation. The stagnant air within the conduit acts as an insulator, trapping heat and exacerbating the risk of conductor overheating. Secondly, the ampacity of conductors, which refers to their current carrying capacity, is meticulously regulated by NEC Section 310.15. This section provides comprehensive tables and guidelines for determining the appropriate conductor size based on a multitude of factors, including ambient temperature, the number of conductors within a raceway, and the type of insulation employed. When the number of current carrying conductors within a conduit exceeds 3, NEC Section 310.15 mandates the application of ampacity adjustment factors. These factors serve to reduce the allowable ampacity of the conductors, thereby preventing them from operating at temperatures exceeding their rated limits. The utilization of oversized conduit does not obviate the need for these ampacity adjustment factors. Failure to account for these factors can lead to conductors operating beyond their thermal limits, resulting in insulation degradation and an increased risk of electrical failure. Thirdly, NEC Chapter 9 provides detailed tables outlining the permissible conduit fill. These tables specify the maximum percentage of the cross-sectional area of a conduit that can be occupied by conductors. These fill limits are meticulously designed to ensure adequate space for heat dissipation and to prevent physical damage to the conductors during installation. Even when the conductors fit comfortably within the oversized conduit, exceeding the prescribed fill limits can still compromise heat dissipation and elevate the risk of overheating. Fourthly, the NEC places a strong emphasis on the proper support and securing of conduits. Oversized conduits, due to their increased weight and dimensions, can pose challenges in terms of providing adequate support. Improper support can lead to sagging, bending, or even detachment of the conduit, placing undue stress on the conductors and increasing the likelihood of insulation damage. Furthermore, the use of mismatched fittings and connectors with oversized conduit can create points of vulnerability within the electrical system. These weak points can be susceptible to moisture intrusion, corrosion, and mechanical damage, all of which can compromise the safety and reliability of the installation. Fifthly, the NEC mandates that all electrical work be executed in a neat and workmill-like manner. The utilization of oversized conduit without a justifiable engineering rationale can be construed as a violation of this requirement. Such practices can result in a cluttered and unprofessional appearance, making it more difficult to troubleshoot and maintain the electrical system. Furthermore, the presence of oversized conduit can impede access to other electrical components, hindering future modifications or repairs. Sixthly, comprehensive documentation is paramount for all electrical installations. When oversized conduit is employed, it is imperative that it be clearly documented in the electrical drawings and within the project specifications. The documentation should provide a clear explanation for the use of oversized conduit and include detailed calculations demonstrating that the conductors are adequately sized and protected. Without proper documentation, it becomes exceedingly difficult to ascertain whether the installation complies with the NEC and to ensure its long-term safety and reliability. Seventhly, the potential ramifications of utilizing oversized conduit without proper conductor sizing are far-reaching and potentially devastating, ranging from equipment malfunctions to electrical fires. Electrical fires can inflict significant property damage, cause severe injuries, and even result in fatalities. In addition to the immediate safety hazards, non-compliant electrical installations can also lead to substantial legal and financial liabilities. Building owners and contractors can be held legally accountable for damages resulting from electrical fires that are attributed to code violations. Furthermore, insurance companies may decline to provide coverage for losses stemming from non-compliant installations. Eighthly, to mitigate these risks and ensure the safety and integrity of electrical systems, it is essential to rigorously adhere to the NEC guidelines for conduit sizing and conductor ampacity. Electrical engineers and contractors should meticulously review the electrical drawings and specifications to ensure that the conduit and conductors are properly sized. Electrical inspectors should conduct thorough inspections of electrical installations to verify strict compliance with the NEC. When violations are identified, they should be promptly rectified to prevent potential hazards. Ninthly, continuous education and training are indispensable for electrical professionals. The NEC undergoes updates every 3 years, and it is crucial for electricians, engineers, and inspectors to remain abreast of the latest requirements. Training programs, seminars, and workshops can provide valuable insights into code changes, best practices, and emerging technologies. By staying informed and proficient, electrical professionals can ensure that their work consistently meets the highest standards of safety and quality. Tenthly, public awareness campaigns can play a significant role in educating homeowners and business owners about the importance of electrical safety. These campaigns can disseminate information about common electrical hazards, preventive measures, and the importance of reporting code violations. By empowering individuals with knowledge, we can collectively create a safer environment for all. Finally, reporting electrical code violations is a critical civic responsibility. If you observe instances of oversized conduit being used without proper conductor sizing, report it to the local building inspector or electrical authority. Your report can potentially prevent a dangerous situation and safeguard lives and property. In conclusion, the utilization of oversized conduit for lighting home runs without upsized conductors constitutes a violation of the NEC. This practice can precipitate overheating, fire hazards, and other serious safety risks. It is incumbent upon electrical professionals and inspectors to understand and enforce the NEC requirements for conduit sizing and conductor ampacity. By working in unison, we can ensure the safety, reliability, and longevity of electrical installations, protecting individuals and communities from the perils of electrical hazards.